The figure below shows the equipment we use in this lab. I will explain about the condition of the disc brake part. So first is the wear indicator. From the figure, we can see the wear indicator is still in the good condition, which is available to use. And then the disc brake surface. Okay, from the test we do, we know that the surface of the disc brake is not uniform. So next is the outboard brake shoe and the inboard brake shoe. The thickness for the outboard brake shoe is 3.46 mm, and then the thickness for the inboard brake shoe is 2.96 mm. So based on the rough test we do, we can see that the surface of both brake shoes are not uniform. Next is the piston and the cylinder bolt. So from the both figure shows in the slide, we know that these two components are still in the good condition, no crash or other things else, so it's reliable to use.
Hi, my name is Chai Sunyan, and in question 1 in discussion, based on the conditions of brake pad, should it be replaced with new pad? Generally, a thicker brake pad will provide more friction material to slow down the vehicles and improve safety. The ideal thickness of brake pad is more than 6.4 mm for proper brake functioning, and the minimum brake pad thickness is 3.2 mm, agreed by most of the car mechanics. Otherwise, thinner than this will be not reliable and immediate replacement is required. Based on our finding, the conditions of outboard and inboard brake pads are different, where the outboard brake pads has a thickness of 3.46 mm, which is slightly more than the minimum thickness of 3.2, and the brake pad surface is even through the rough test, so it should get replacement soon for that thickness. While for the import brake pads, it has a thickness of 2.96 mm, which is less than the minimum thickness required, and the brake pad surface is uneven through the rough test as like the pictures, so immediate replacement is required to avoid brake failure.
Hello, sir. My name is Ho Kim Fat. Now I need to talk about the discussion number two, which is the list two causes of the rotor thickness variation, and what is the correct repair procedure of thickness variation. So I talking about the first question. So the first one is an excessive lateral run out, which is you can see the right side of the diagram. You can see that the motor of the display will like got a stiffness. So this is the diagram lah. And then so when the lateral run out, you maybe will cause that the wear of the brake pad will got the flat spots of freckles on the brake disc. So this is the general causes to make that the rotor stiffness variation. So what is the correct repair procedure for this situation? So before you presses the indicator budget, you make sure that you already assemble the brake assembly on the mount and tighten the screw. Because when you do not tighten the screw, maybe you measure the run out, maybe the rotor will moving. So before you place the indicator, make sure that you already tighten all the brake assembly. So after that, you presses the indicator budget at the point 30 millimeter from the upper edge of the disc. So you set the indicator to the zero, means that the needle is to the zero. After that, you rotate the disc and then see the needle, record the measurement. Make sure that the out should not be excess 0.05 millimeter. So after this, is finished. Thank you.
Hello everyone, my name is Satish Analaki Ganesh from BMMA 2/1. Today I'll be presenting the question 3. What do you understand about runout measurement data? The runout measurement data is a technique for determining the high spot of a brake rotor and the variation thickness. We can tell whether or not the rotor meets the manufacturer's specification based on the data above. To obtain the high spot value, a dial gauge is used. This method of measuring runout involves locating the dial gauge point of contact toward the rotor and rotary of the rotor. Thank you.
Okay, next is question 4. What is your finding for the guide pin or lock pin straightness check? And what can happen to your disc brake system if guide pin or lock pin is not straight? Okay, from our finding of the guide pin or lock pin straightness check, it was in good condition. We ensure this condition by perform a circular motion test on the guide pin. When a force applied to the guide pin for for the circular motion test on this grounded surface. It it was never stuck on while rotating in a motion. It was rotate in uniformly rotate. And next question is, if the guide pin or lock pin is not straight, the guide pin is responsible for guiding the proper angle for how the brake pad meets the disc. If the guide pin is not straight, the caliper is not free to move. It it, it is the reason it the it might be bent or binding guide pins. If the guide pins is not straight, we'll experience noises or problems on stopping. The brakes could stick could stick or grab when you are driving, or you could hear a grinding noise if the calipers aren't meeting the rotor at the proper angle. It means the brakes could stick or grab while you started to accelerate the pedal, although you never press the brake pedal. Thank you. Okay. Conclusion. Finally, based on this lab, we done inspecting the condition of this brake for each and every parts of it. It also teaches us how to properly examine this brake and its parts. This lab session also allows us to assemble and dismantle the world this brake system. Furthermore, this lab experiment allows us to identify all of the components of a disc brake assembly and their names. As a result, the lab session is completed properly in the correct order by referring the lab sheets given. Thank you.